Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 2542 that says maximum subsequence score. So this question is a very good greedy question and will ask you to open up your mind and do a little bit of brainstorming. So yeah guys, solving this question will help you realize that how good an observation can be made and how a complete approach can be derived from one simple observation. So yeah guys, stick till the end and watch the complete video. Now here you are given two integer array nums1 and nums2 of equal length n and one positive integer k. Now you need to select k indices from nums1, okay, sum them, and for the same indices choose the minimum element from the nums2. Okay, so the task is to select k indices from the array of length n, and in the nums1 sum all these k indices, and in the nums2 find the minimum of those k indices and then multiply these two, multiply the sum and multiply this minimum element of the nums2. So yeah guys, that way we have to find an answer that is maximum possible, right? Maximum possible score. So this is defined as a score by choosing k elements from nums1, doing that sum, choose the same k indices of nums2 and find the minimum of them, and then the product. Further, what is a subsequence? A subsequence is nothing but a set of indices by deleting some or no elements. Okay. Now if you take a look at the first example here, nums1 is 1 3 3 2 and nums2 is 2 1 3 4 and k is 3. So yeah, one option is we can choose index 0 1 and 2. Index 0 1, let me just number them. So we can choose index 0 1 and 2. So the same indexes element from the nums1 we will sum them, and the same index element from the nums2 we will find the minimum, right? This sum is nothing but 7 and the minimum is 1, so 7 into 1 is 7. Similarly, we could have choose 0 1 and 3 because this is a subsequence where we can delete any elements. So yeah, we have deleted the element index 2, and we can get 0 1 and 3 as one subsequence. So then we would sum the elements of 0 1 and 3 and find the minimum of 0 1 and 3 from nums2, and yeah, the product of them would be our score. So likewise, we have to take different indices in order to find the maximum possible score. So at one point, if you would select indices 0 2 and 3, will result you a score of 12, and this is the best possible answer for a given nums1 and nums2. Okay, so I hope you guys have now understood what we are trying to do in the question. We are simply trying to choose k indices from the given n numbers. So yeah, we have total n numbers, and from that we are trying to choose k numbers, right? So these are the sum of the ways in order to choose k numbers from the given n numbers. Here in the second example we have k equals to 1. That means we have to choose only one element. Then it is pretty much simple, right? For each we will just do what? We will simply multiply them, nums1 and nums2. For each I we will simply multiply them, and the maximum product you will get it by the index 2. That means 3 multiplied by 10. This will give you the maximum product, right? And that would be our answer. Since k is equal to 1, we will simply multiply all the indices, right, of nums1 into nums2. Correct. So guys, if you think here of a brute force approach where you will try to find all k combination, then that would be nothing but n combination of k, n ck, that is nothing but n factorial divided by k factorial into n minus k factorial. Since we are trying to choose k elements from n elements, right, we are simply trying to choose. So this is the formula of combination, right? And here n is n can be up to 10 to the power 5 and k can be up to the same thing. So yeah guys, if you think that 10 to the power 5 factorial, then this is a too large number. And if you try to go with this approach by finding all the key combination, then it will be sure that you will result into time limit exceeded. So guys, we have to find some better approach, right? This is not an efficient approach. So guys, for that, suppose we have this type of nums1 and nums2, right? We have these elements in nums1, these elements in num2, and k equal to 3. Okay, just assume that this is the given example. Now here let's try to solve this question. So what we will do here is we will choose the minimum element from nums2. We will choose one element as, let's say, the minimum element, right? And then we would try to find the answer. Okay, so for an example, let us choose this element as the minimum element of nums2. Now after that, what choices do we have? See, after that we can select this. We can select this indices. So let me give the indices. So here initially at the step 1, we have selected index 1 and the nums2 representing as the minimum element. Then afterwards we have choices of these indices because 6 is greater than 3. See, this is the minimum nums2 element. So afterwards we can take all the elements that are greater than the minimum, right? We can take this combination, right? We can take this combination, we can take this combination, and we can also take this combination, right? Because at all three places the nums2 element is greater than the minimum element we have chosen, correct? This is 4 is greater than 3, 9 is greater than 3, 6 is greater than 3. So yeah guys, if we choose one of the element as a minimum element, then we would check for all the indices where nums2 of j is greater than the current minimum. So these are these three possible. See, we can't take this because we have considered this as a minimum element. Now if you would take this index 3, then that nums2 would be lesser than the minimum that we have chosen. So this is not correct. So yeah guys, as you can see that if this is the minimum element, then from the nums1 we can either choose 2, 5 or 9. So from this set 2, 5, 9, this is the set. From this set we have to choose what? We have to choose remaining k minus 1 element. One element is already chosen, right? This is already chosen. So what is the k? K is 3, k minus 1 is 2. So we will choose, we will try to we need to maximize the score. Okay, so we will choose the maximum elements from nums1, right? We will choose 8 and 5. Okay, see, sorry, this is 8. We will choose 8 and 5 because we need to choose 2 elements. So we would choose nothing but the maximum 2 elements. So yeah, 1 was fixed, 3 was fixed. From nums1, 3 was fixed, and the another 2 are 5 and 8. Okay, and the minimum of nums2 is nothing but 3. Okay, so yeah, this way you can get answer 54. Got it? Okay, so this is one approach. Now let's say if you would have chosen, this index 4 as the minimum element, then the nums2 minimum element would be number 4. Now after that you can take any indices with nums2 greater than 4. Yeah, we can take this as well as this because both have nums2 greater than 4. So now we don't have to now the nums2 or this thing doesn't change. As the minimum element is 4, this thing doesn't change. We only have to concern about nums1 and selecting the best possible nums1. So here, since we have only two choices, we will take both of them to our answer and calculate the answer. But if you see here, the answer is 60 and this is a better answer than this. Okay, so guys, our observation here is if you select an element from nums2 as a minimum element, then we have to only select k minus 1 choices. That means we have to make k minus 1 choices to select nums1 where nums2 of j greater than nums2 of I. So if you have selected this nums2 of I as a minimum element, then we have to make k minus 1 choices to select nums1 of I where this condition is satisfied. Okay, got it? I think that this might be a bit complex for you to understand, but this is it, right? This is not even that that rocket science thing we are doing. We are simply selecting one element from nums2 and declaring this as a minimum element. Okay, then after that, what are the choices we have to select other k minus 1 element? We can only take those nums2 of I, those indices where nums2 of I is greater than the minimum element we have declared, right? As the minimum element would change. See, we can't, if we have declared 4 as a minimum element, then we can't take 2. We can't take this. Why? Because the minimum element would change. So we don't want to change the minimum element from nums2. Then in that case, we will only take all these indices when nums2 is greater than the minimum element. So yeah, we can take this and this. So that's was our observation says that if we select any nums2 of I as a minimum element, then we have k minus 1 choices to select nums1 of I where nums2 of j is greater than nums2 of I. That means the new indices or new choices we have to make, those elements must have nums2 greater than the minimum element that we have declared. Okay, clear till here? Now further, what are the two tasks that we are doing here? So after declaring nums2 of I as the minimum element, our one task is find the set of element when nums2 of j is greater than equal to nums2 of I. Okay, so what we did here, so after declaring 3 as the minimum element, we have to find all the indices where nums2 of j is greater than nums2 of I. Okay, so these are set is nothing but this index 0, index 2 and index 4. Okay, this is the first step we are doing. And the second task that we are doing is choose the k minus 1 element with maximum nums of I value. So here, since we have option of index 0, index 2 and index 3, we will choose only 5 and 8 because those are the maximum nums of nums1 of 5. Okay, nums1, those are the maximum element from nums1, right? So, from the three choices, set of 3 elements, we have to make a choice of 2 elements. So yeah, we will choose the maximum that has maximum nums1. Okay, because we want to increase the sum, so we would choose the maximum. So currently we are doing 2 tasks. After selecting one element as a minimum, we are doing 2 tasks: finding the set of all the elements with a nums2 greater than the minimum element we have declared, and from that set, so this will create one set of elements. So from that we are choosing k minus 1 element with a maximum nums1, with a maximum value of nums1. Okay, this we are doing here. Now in order to do this task 1, we will perform step 1. In order to solve this, right, we would perform what? We would pair up nums2 of 5 and nums1 of 5 and sort on the basis of nums2. Okay, the first question that would arrive in your mind is why we are pairing up nums2 and nums1. This is because the ith element of nums2 and nums1 must be remain same. See, if we would sort on the basis of nums2, we would shuffle, but we don't want to lose the sequence, right? Or lose the sequence of nums2 and nums1. See, initially for this example, if let's say 0 1 2 3 4, if these both were the same ith element, then let's say after sorting, they come at the end. Let's say they come at the end, but the pair of 5 and 9 must remain same, right? You cannot make a pair of 8 and 9, right? We cannot make the ith element of nums1 should pair of ith element of nums2, right? We cannot change this thing. So we cannot lose the index of nums1 and nums2. That means the ith element or the ith index of nums2 must remain the same for the ith element of nums1. These two things must remain same. So yeah, we would pair up and then sort on the basis of nums2. So how that will help? So if you would sort on the basis of nums2, then we don't have to check for this, right? If you would sort it, let's say for an example, let's say just simply take nums2 as something like this. Nums2 as, let's say, 5 3 6 2. After sorting, you will get something like this. Let's say we are sorting in reverse order: 6 5 3 and 2. Okay, now suppose you have chosen this as a minimum element. Now we don't have to find the set where nums2 of j greater this thing we don't have to find this, because all the element previously present would have values greater than this, because this is sorted in descending order. So the previous element would be nothing but values greater than this thing. So we don't have to check for all the n elements, right? Once we have sorted, then this thing is this task 1 is simplified, right? If we had sorted on the basis of nums2, then this task 1 is simplified. Now for the task 2, to choose k minus 1 element, maximum element, what we would do is we will store k minus 1 elements of the nums1 into min heap. Now why min heap? This is because in the min heap we want k minus 1 maximum elements. Now in order to store that, we took min heap because whenever a new element arises, we would check whether the topmost element or the minimum element in the min heap, if it is lesser than the current element. If this is the case, we can pop that lesser element and push the better element. So this is how we would only have the maximum possible k minus 1 elements in the nums1, right? We would have maximum possible k minus 1 elements in the nums1. So guys, these things might be a little bit confusing, but yeah, once we will do a dry run along with the code, then I am sure that you will understand all these things that we are discussing. Okay, so without wasting any much of our time, we would simply move on to the dry run. So for the dry run, here I have taken this nums1, nums2 and k. Okay, now first thing that we were doing here in the approach part was to pair up in the nums array. So we have paired up, right? We have paired up 2 and 1. So we are pairing up nums2 with a nums1. The first element is nums2, right? So we have paired up these elements like this way. This is 2 and 3. So guys, after pair up, our nums array would be something like this, where the first element is a nums2 part and the second element is a nums1 part. Okay, then afterwards we sort in the descending order. Now since we store the first element as nums2, then this will sort on the basis of nums2 in the descending order. So this is the sorted. So the first element would be 4 comma 2, then 3 comma 3, then 2 comma 3, 2 comma 1, and 1 comma 4. So here we have sorted this nums array based on the nums 2, right? 4 3 2 2 1. See, you can see 4, then 3 2 2 1. So we have sorted based on the basis of nums 2. Okay, now afterwards, see, we have k equals to 3. Then afterwards we are storing k minus 1 elements inside the min heap, and also we have maintained one current sum. So min heap will contain, see, inside the min heap we are only storing nums 1 element, right? So here the min heap will contain 2 and 3. See, this is 0 1 2 3 4. Now we are storing k minus 1, that means first two elements nums 1 into our min heap. So min heap contains this 2 and this 3, and the current sum becomes 5. That is the sum of all the elements inside the min heap. This is the current sum. Now guys, afterwards this is where the actual calculation begins, inside this for loop. So now what is the k minus 1 elements? K minus 1 element, that means I equals to 2. Now here we will declare I equals to 2 as the minimum element. Nums 2 of I, this nums 2 of I, that means I equals to 2 is the minimum element. Now after that we can select all the numbers that are before previously present, right? Because all have greater nums 2, nums 2 is greater. So yeah, this is that step. Okay, since this is already sorted, we can select any elements from the min heap for the nums 1 part. Okay, so k minus 1 elements were already present in the min heap, and that sum was already present in the current sum, right? So this is nothing but sum of k minus 1 element, and this is nothing but the ith element. So we have added the ith element into our current sum, and then we perform our answer. That means the score is nothing but the maximum of previous score, else the current sum multiplied by the current nums 2. So nums 2 is what present at the first pair. In this pair the first element is the nums 2. This is the minimum, right? See, this is, so currently we are checking for the index 2, and the minimum nums 2 is 3. So till here this is our window, right? This is our window. In this window the minimum nums 2 element is 3. Sorry, not 3, my bad, not 3 but 2, because the first in the pair the first element is the nums 2. So the minimum element in this window is 2, right? So we have simply multiplied 5 plus 3, that is 8 into 2. Now after that we are updating our min heap. Now in order to update our min heap, we check whether the topmost element of the min heap, if it is less than the current element, right? Then yeah, it is this. See, this was the topmost element previously, and that is less than the current element. Current element is what? It is 3. Current nums 1 is 3. So yeah, we update the min heap to this new, that is 3 comma 3. We remove this topmost element that was minimum and replace it with this new current element, because that is better than the minimum element. Thus at this point the min heap will have maximum k minus 1 element of the nums 1, right? And also we change the current sum to 6, that is the sum of elements inside this min heap. So yeah, in the next iteration, we are taking this index 3, we are declaring this as a minimum element of the nums 2. Then we have this window. So from this window we can choose any element of the nums 1 that are best. So that would so our min heap would help in this case. So our current sum is 6, and 6 plus 1, that is the current nums 1 is 1. So there is 7 multiplied by 2, because the current nums 2 element is 2. This is your current answer. Now again we will check. So the previous min heap was 3 comma 3, and the current nums 1 element is 1. Can we get better? No, 1 is already less than the minimum. So yeah, we won't insert 1, and this would remain as it is. Now in the next iteration, for I equals to 4, this would be, we would change our current sum, that means the previous sum, plus the ith, that means the 4 nums 1 of I we are adding, then performing the answer and simply updating min heap, because the previous minimum element is 3 and the current element is 4. So current element is a better than the previous minimum. So yeah, we change. Now after this loop will end, because we have traversed over all the elements, and at the end we return the answer. So yeah, I hope you guys have understood this question. Now I will ask you that if you still have any doubts, and if you are not getting clear that what we are trying to do, make sure you try to make a dry run yourself. Take this code and try to do a dry run, right? If you would do that, then only you will get a better understanding. See guys, this is a greedy approach, and in most of the greedy approaches, it is very much difficult to make you guys understand that how to build the intuition and how to approach the question. The greedy approach is one of the hardest, you can say hardest algorithm to understand, right? So for any naive people or anyone who has started learning data structure algorithm, the person would think that yeah, DP is one of the hardest algorithm, but that is not the case. DP is easier to understand as well as code. Greedy problems are harder because forming an intuition in a greedy approach is difficult. Forming the intuition for DP or graph problems are easier because there is a pattern. There is a pattern in DP problems as well as graph and tree problems, but there is no such pattern in greedy problems. So yeah, that's what it makes a greedy problems difficult to code and difficult to build an intuition. So yeah guys, if you solve a tons of greedy problems, then you will realize that greedy is much more difficult than dynamic programming. So yeah guys, that's all for this question. Now let's discuss about the time and space complexity. So here the time complexity would be, first we are doing sorting, then we are using heap, k minus 1 elements in heap. So this sorting would take n log of n, and this would take log of k minus 1 for each time we are inserting and deleting the elements. So this would be the time complexity. And space complexity would be extra nums array, nums of pair we are using and heap we are using. So this would take big O of n, and this would take big O of k minus 1. So this would be our space complexity. So yeah guys, that's all for this video. If you guys have still any doubts, then do let me know in the comment section. Make sure you like the video and subscribe to our channel. Thank you.